What's up, everybody? Once again, Joe from Flysimware Simulation Software here with part 2 of our video manual series. Real quick video here for you. If you made it through the last hour and 10 minutes of the introduction, good for you. Congratulations. You now have a really solid understanding of the systems in this airplane, which is why we're going to move on now real quick in the next couple of minutes and just talk about one of the very important systems in the 441, and that is the start locks for the Garrett engines. I know there's been a little bit of confusion. People think they're part of the NTS system. They're really not. That confusion just comes from the procedure that you use to return the propellers to the start locks, and once you understand that, you'll understand where the confusion comes from. But no. So we're going to talk about the start locks on the Garrett TPE 331 engines. Tiny little bit of background here, just so you understand why we're doing this, and then I'll cut right to the chase, and this should be a pretty quick video. The Garretts, as we've talked about, are gear drive engines, so they are not free turbine engines. The starter motor, when you press the start button and the starter motor begins to turn the engine, it's turning everything. It's turning the jet engine, it's turning the gearbox, and it's turning the propeller. So if you were to physically walk up to the propeller and turn the propeller by hand, you are turning the prop, the gearbox, the engine, the whole thing. It is all connected all the time. Which is very different than a free turbine engine like you find on a PT6 or a Dash 8 or an ATR or airplanes like that. The C-130, for example, Allison T-56 engines. The C-130 also has gear drive engines, very similar deal. So the advantage to gear drive engines is that the throttle responsiveness is very similar to a piston-powered airplane. There is no real turbine lag. The power is pretty much on command all the time. Something we wish we could have simulated for you in Flight Sim, but it's just not possible to simulate that and get you stable power response. So that's a huge advantage to gear drive engines, is that the power response is simply phenomenal. You also get better horsepower output, more reliability. It's just a more bulletproof engine. But it has a lot more moving parts, which is why they're not as popular, and they're not quite as common as free turbine engines, because free turbine engines are a lot simpler, even if albeit a little bit less reliable. Having said that, because the engine and the propeller and the gearbox are all one assembly, they're always turning together, it requires an enormous amount of power to start the engine. Even with a full battery, you're getting maybe 2 or 3 engine start attempts before you kill the battery, or before you draw the battery to the point where you can't start the engine anymore. They draw a tremendous load, and they put a lot of wear and tear on the battery. So it's very important that the engine accelerates as fast as possible. So we'll bump into the external view here. You'll notice that the propellers are very flat. I mean, if you look at them from the side, I mean, they're not like pitched at all. They are almost completely flat. Being in that flat pitch is referred to as being on the start locks. And the reason that that flat pitch is the start lock per se is because it results in the least amount of air resistance on the propeller when it's starting. And that's why the propellers on Garrett-driven engines, when you look at them shut down, are always flat like this and not feathered like they are, you know, when you see a King Air sitting on the ramp or anything like that. It's because we need these propellers to be as flat as possible when we start them, so that the engine can spin up quickly and not draw a lot of power. So there is no procedure for starting these engines unless they are on the start locks. Unless they are in the flat pitch on the locks, you're not starting the engine. The engine won't start. If they are pitched, or if they are in any position other than flat, the engine will not accelerate fast enough to start. It'll try to, but the engine will end up spooling up too slowly, and the fuel computer will introduce the right amount of fuel thinking it's spooling up at the right speed, and the long and the short of it is the engine won't be turning fast enough to exhaust the hot gases fast enough, and you'll end up with either a hot start, or if you have a weak battery, you can end up with a hung start. So having said that, we'll hop back inside now. So having said that, there is a procedure for the start locks. You have to remove the propellers from the start locks prior to taxi, after engine start, and you have to place them on the start locks again during the shutdown procedure, so that they will be on the locks for the next engine start. And then thirdly, there is another procedure to follow should you forget to put the propellers on the start locks and they end up off the start locks. So give me 2 seconds, I'm going to fire up these engines and I will show you how to remove them from the start locks. Okay, so here we are, engines are running, and we're ready to taxi, so to speak. So we'll notice that we just started the engines, the way that we know that they're still on the locks is that we push the throttles up and we get no thrust. Now in real life, you'll be able to actually move those throttles up ground idle at all. They just stay stuck. So here's the procedure for removing them from the start locks. You're going to momentarily pull the throttles down into reverse, and then you're going to come right back up to ground idle. So just like this. That's it. And you're off the start locks. Now you have full power, full range, and everything. You're off the start locks. So now, for procedure for putting them on the start locks when you shut the engines down. So we're going to go ahead and turn off our generators. Fuel boost, turn, radio exhaust, okay, ready to shut down. We're going to push the left and right stop buttons, and once we press the stop buttons, both power levers need to be into full reverse before our RPM deteriorates below 50%. So before we're idling at 70, before we drop below 50, we need to have it in full reverse, and they have to stay there until your RPM has deteriorated below 20. So for between 50 and 20, for that window there, of that 30%, the throttle or the power levers need to be in the full reverse position. Good practice, just leave them in full reverse until the prop stop. Alright, so here we go. Show you now. Left shut down, right shut down, into full reverse. You'll see that our engines are spooling down. Okay, and now we are back on the start locks. Now we can go ahead and move those right back up to ground idle. And that's it. You're on the start locks. Those props are going to stay nice and flat for you just like that. So now, give me 1 second, and I will do an engine shutdown without following that procedure, show you what happens and how to fix that. Alrighty, so like we said before, here is an example of a nice... Oh, crap, that was a lot faster than I wanted it to be. There we go. Here's an example of a nice prop flat on those start locks, exactly the way we like it. Nice and flat. Let's head over to the left engine. This is what happens when you have a propeller that is shut down and is not on the start locks. So if you forget to do the procedure to engage the start locks prior to engine shutdown or during engine shutdown, this is what you will end up with. The prop isn't feathered, but the prop is not flat. It's in sort of a flight range pitch, and this is not what we want. This is too much air resistance. You will not be able to get the engine started if this happens. So if you do not follow the procedure, this is what you will end up with. And it may take 2 to 3 minutes after engine shutdown. Sometimes you'll see it instantaneously, sometimes it takes a couple minutes, but either way you will see your propeller just like this. This is not what we want, and now I'm going to show you the procedure for undoing that. Okay, so in the cockpit with the power turned on, here is the procedure that we're going to follow to get that propeller rotated back the way we like it. So, very simple. What we're going to do, and I'll just really quick get out of here, and I'll try to catch this prop coming around for you. It's a little tough to see from the virtual cockpit, just because of the angle. So I'm going to go right there. Alright, so here's the procedure. Very simple. You want to pull the engine in question, so in this case it's the left engine, pull that throttle down all the way into reverse, and then that unfeathering switch that we used to do our NTS check, which you're going to see in the engine start video. This is the real purpose of the switch, which is to unfeather the propeller. You're going to hold that over to the left. In this case, just click it with your left mouse click. And just click it over to the left as long as that left throttle is down in full reverse, and that will get that prop back on the lock. So I'm going to click it and switch to the external. And you'll see there comes the prop right around. And there you have it. You're back on the start locks in that flat pitch the way we like it. In real life, that uses up a ton of juice in terms of electricity, so we try never ever to do that. That pretty much wraps up start locks, and now you guys should all be experts in the proper startup and shutdown of the 441 and using those start locks the way that they were intended to be used. Next video, we'll do an engine start, and I'll show you the normal procedure for an engine start. Alright, Joe from Flysimware, thanks for watching. Fly safe.